Hi everybody, this is the recording lesson or the video lesson for Wednesday, March 8th. First of all, if you are listening to this video, it's because you're either absent today or you have finished your MAP testing in science. If you still have to do your MAP testing in science and you are in my classroom right now, please stop watching this video and make sure you come and talk to me and so that I can get you connected to your MAP testing. Okay, so our objective today is I know why different substances have different properties. We're going to be in Chemical Reactions 1.4. Here's what you guys are going to do today. You're going to watch the lesson video. I want you to copy the Atomic Zoom In. It's an article that you're going to be reading today. There are 4 pages, I believe. The digital copy is in this folder. I do not have hard copies at all because for this unit, the elements that we're going to be looking at are actually colored. So the molecules and the atoms are color coded. And so it's actually really important that you see those colors. They don't come across correctly if I print them and they're just in black and white. So you'll have to use the digital copy. And then at the end of the class, you'll be able to submit your annotations to Schoology. Make sure that you don't just skip this video and read and annotate, because I'm going to go through the little bit, like the first part of the article with you to show you what I want you to do. And then I'm going to be walking you through a couple different things and just making sure you understand the concepts that are coming up. Okay? Your homework for today is to study vocabulary and the key concepts for 15 minutes today, tomorrow, and every day. All right, so we're going to do the activity 1 warm-up. I want you to go ahead and log into Amplify 1.4. And this is showing a bottle of water and a bottle of cooking oil. We can assume it's like olive oil or vegetable oil. And they're both liquid at room temperature. What are some properties that oil and water don't share? So go ahead and write those down. And then write down your idea of why you think they have different properties. Go ahead and pause the video, do that, submit it, please, and then start the video again. Okay. So we know that different substances have different properties. That's key concept number 1. And that when we compare properties, that's one way for us to tell substances apart. We can tell by the texture, we can tell by grain size, or we can tell by smell sometimes. But we can see that the oil and the water have different properties, but what we don't know is what gives them their different properties. And that's what we're going to focus on today. Question we're going to be investigating today is why do different substances have different properties? We're going to begin investigating why different substances have different properties by watching a video. Now, you guys have this video in your digital resources in Amplify. If I played it, I think it would have too much like feedback, I think. So what I'd like you to do is escape or get out of this video, pause it, and then go into Amplify, and in your digital resources, you can see this video. If you can't find it, come up to my desk and ask me where it is. And then when you get done watching it, come on back to this video and keep playing. All right, so questions or comments that you might have about the video, let me know. You can raise your hand, come back to my desk if you have any specific questions. And if not, then let's go ahead and move on. So just a reminder, we've had the word scale before. Scale just means the relative size of things. And the scale that's visible to us is the macro scale. Hopefully you guys remember that from the previous lesson. That's what can be seen with the naked eye. Atoms are on a scale that are too small to see, and so we call that the macro scale. We're going to be we're going to be building on what we learned in the video by reading and annotating an article about atoms. If you haven't yet, go ahead and go into today's folder in Schoology and please copy the digital copy of this article into GoodNotes, into your Chemical Reactions folder, and then come on back. Okay, so at the top of your video, what I'd like you to do is I want you to put the investigation question, why do different substances have different properties? And I wrote that in red because when I find the answer in the article, I'm going to also write that in red so that I know that it kind of comes back and ties back to this investigation question. I also want you to number your paragraphs. This is a long article, and so I'm going to be referring to some paragraphs later on. After you read and annotate, we're going to be discussing a couple things. And I want to make sure that you guys know what you're talking about, that we're on the same page in the same paragraph. So go ahead and take time to number your paragraphs. Couple things very quickly. We've got 2 vocabulary words that we've used quite a lot in class, but we haven't actually identified them as vocabulary terms. And so the first one is atoms. And atoms are the tiny pieces that all matter. In other words, all the stuff in the world is made of. I think this definition is kind of complicated. You can just say atoms. Everything is made of atoms. I've heard people refer to them as the building blocks of matter. That's very true. Everything is made of atoms. And then substance. Substance is something that is made up of all the same atoms or groups of atoms. And in fact, in your vocabulary, after that, I put a parentheses and I put molecules, because we learned in the previous unit that molecules are also known as a group of atoms. Now, in the article, I'm going to identify the vocabulary terms one time, the very first time, and I'm going to do that by circling them in green. And then from then on, I'm not going to continue to identify them. I can recognize that we're using the words atoms and substances. All right, so let's take a look at paragraph number 1. So it says, imagine you're eating breakfast. I'm going to model your annotations in this first part, and then I'm going to let you go ahead and complete the article on your own when we're finished, okay? Again, I just want to remind you, by this time in the year, your annotations don't need to be, wow, that's cool. In fact, I don't want those. I only want scientific annotations that are going to tie back to the investigation question, why do different substances have different properties? So let's go ahead and begin. Imagine you're eating breakfast. The wooden table you're sitting at is hard, your orange juice smells sweet, and the sugar in your sugar bowl is white. The day has just begun, but you've already come into contact with many substances, each of which has its own set of properties. So as soon as I get done reading that, I'm like, wait a second, that sounds awful familiar. Many substances have their own set of properties. That's key concept number 1. So go ahead and I'm underlining, you can highlight. And again, I want to circle certain words that are important. And we've got properties, key concept number 1. What is it that gives these substances their different properties? Well, substances is one of our vocabulary terms, so I'm going to go ahead and circle that. To understand where these differences come from, scientists observe substances at a very small scale, much smaller than we can observe in our daily lives. Let's zoom in and see what we find. What is matter actually made of? So just kind of summarizing this last little bit, in order to answer our investigation question, notice I have that kind of boxed in red. We have to look at the, and I said macro scale, that's wrong. I'm changing this really fast. We have to look at the molecular scale. All right. Molecular scale. Paragraph number 2. In the 1800s, John Dalton was the first to propose the idea that all matter is made of tiny pieces called atoms. Hopefully you guys read John Dalton and you went, wait a second, we studied John Dalton. We know exactly about John Dalton and his atomic model. It's important that we identify the word atoms. That's one of our vocab words. And I want to remind you that John Dalton had the billiard ball model. And go ahead and draw 3 circles. Make one white, one is red, and one is black. That's important because in today's article, they're going to use Dalton's model. Do you guys remember when I told you about John Dalton? I said a lot of times in schools and in textbooks and even scientists will use the billiard ball model when they're describing atoms just because it's easy to work with. It's easy for us to use colored circles to represent atoms. And so that's what we're going to do in the article. And in fact, in the rest of the unit, we're going to be using the billiard ball model to talk about different individual atoms and then as they come together to form molecules. Today we call this the atomic theory. Since it is a theory, it may sound like scientists are not sure about it, but a scientific theory is actually an idea that has a lot of evidence that many scientists have gathered over a long time. Even today, scientists continue to gather evidence that all matter is made of atoms. That's the definition of atoms. Atoms are the building blocks of matter. Everything that has matter is made of atoms. Okay, paragraph number 3. Atoms are too small for us to see, but scientists currently know of 118 different types of atoms in the universe, including oxygen, carbon, silver, and gold. So these are examples of atoms. Every substance is made of a unique combination of atoms. Substances can be made of just one type of atom or a specific group of atoms that repeat over and over again. Let's go ahead and underline that. That's actually really important, and it's also kind of heavy. Substances can be made of just one type of atom that repeats over and over and over again. If you look at the top of your front page, we've got that picture of a diamond, and then they have a model, because those are not the real atoms, but they have the model of the carbon atom repeating over and over and over again. So that creates a diamond. So this sentence is substances can be made of just one type of atom, okay, or a specific group of atoms that repeats over and over again. For example, you could have, I'll talk about that in a second. Because this is a very, very important idea for you to understand and grasp so that you can move forward, I summarized it out in the margin here, and I want you guys to copy that, okay? So substances are made of either one atom repeated over and over again or one molecule repeated over and over again. Remember, a molecule is a group of atoms. Chemists represent these groups of atoms using chemical formulas, letters and numbers showing the types and numbers of atoms that repeat to make up a substance. So these chemical formulas are letters and numbers. The letters come from the element, so hydrogen and oxygen. And then the numbers tell us how many of each of those atoms that this molecule has. And so one hydrogen dihydrogen oxide, means that I've got two hydrogens and one oxygen. That's water. And then carbon dioxide is one carbon and two oxygens. So that little small number 2 is telling me how many of those individual atoms I have in a molecule. Substances have different properties because they're made of different types and numbers of atoms that repeat. So I am underlining this in red because it answers my investigation question. Remember, we were wondering, why do different substances have different properties? And it's because they're made of different types and numbers of atoms that repeat. There's my answer. And again, that's why I have it in red. If you want to, I don't think you can. Is this on a different page? No, this is all on that front page, right? Yep. So you can just kind of circle that and bring that up, tie that back up to your question if you want to. And then I went ahead and wrote the answer. Different properties mean or equals different types and numbers of atoms that repeat. So a lot of times, different matter, different substances share the same element in their chemical compound, but they have different properties because of the different arrangement or the different collection. And you're going to read a little bit more about that in the rest of the article. So for right now, I want you to pause the video and then hit play when you're finished reading and annotating the rest of the article. You're going to start with paragraph number 4, and the title of this section is How Atoms Make Your Orange Juice Smell Good and Your Socks Smell Bad. Okay, go ahead and read it and annotate. Do kind of what I did. No need to do a lot of annotation, but you have to show me what you're thinking in the margin and how it kind of connects with the whole idea of different substances have different properties. Okay, go ahead and pause the video, keep reading and annotate, and then come back when you're done. Okay, so you are finished reading and annotating. Just a couple things that I'd like to talk about from the article to make sure that you caught it. It can be a little confusing with all the talk of the different chemical compounds. Before we do that, I want to see what you've done on your own. So I don't want to talk about anything and then have you fill in the blanks. So I would like you to go ahead and turn in your annotations of this article. So you'll turn in all 4 pages, turn in the entire document. And the name of the assignment is Atomic Zoom In Annotations. Go ahead and do that right now and then continue the video. All right, what I'd like to talk about is on page 2. So this entire page, you're reading about 2 different chemical compounds or substances that share the same atoms. So the first one is ethyl butyrate, and the next one, the one on the right, is isovaleric acid. And so the interesting thing is that these 2 substances share the same kind of building blocks in that they both have hydrogen, oxygen, and carbon molecules that make up this, or carbon atoms, sorry, I should say, that make up the molecules. So I wrote down the chemical formula for each one, and I want to talk about those. So ethyl butyrate is C6H12O2, and isovaleric acid is C5H10O2. So you can see that even though that they have the same types of atoms that make up those substances, because ethyl butyrate has 6 carbons and 12 hydrogens, the resulting property is that it is a citrus-smelling substance that's added to orange juice so that the orange juice smells like orange juice. It smells good. It smells appetizing. People want to drink orange juice because they can smell that, right? But by having 1 less carbon and 2 less hydrogen, now you have isovaleric acid, which is what makes your gym socks smell so bad. It's crazy to think of just 2 hydrogen atoms and 1 carbon atom making such a difference, but it does. Another thing I really want to point out is not only is it the number of atoms that make up this molecule, but it's also the arrangement. Take a minute really fast and look at where the red oxygen atoms are for the ethyl butyrate. They're in the middle of this molecule, and the carbon is kind of in a strand going kind of straight down, and then the hydrogen is kind of on both sides. Now compare that to the isovaleric acid. First of all, the oxygen is on the right side. And secondly, the carbon molecules are not in a straight line. They're kind of bunched up. And you've got this 1 lone hydrogen that's actually connected to an oxygen, whereas in the ethyl butyrate, there is no oxygen connected to a hydrogen or to an oxygen. Hydrogen and oxygen. Sorry, I don't know if I said that right, but you get what I'm saying. So the two things that are important in the substance, even though they share the same atoms, they share the same building blocks. The way that they're arranged and the number of those atoms really gives that substance its traits, its physical traits as well as its chemical traits. All right. So let's reflect on and discuss the possible answer to our question. Why do different substances have different properties? Well, hopefully I see in your, I don't even know what this is. I'm not going to lie. Oh, go into activity 3, screen number 3 and Amplify. And then answer the reflection question. I think that's actually about, like, did that help you understand this investigation question? Do you think your understanding is better after you've read the article and you've annotated and all that stuff? Okay? All right, I do have a little bit of homework for you today. I think it'll be fun, though. For this activity, you're going to re-watch the Everything is Made of Atoms video and then use the Investigate Atoms, the scale tool. Let me show you where this is. So in Amplify, oh, here it is. In Amplify, that is figures. Let me log in really quick, you guys. I'm sorry. I'm trying to do two things at once, and that's not working very well. All right, so we are in activity number, or lesson number 4. So this homework assignment for you guys, if you go in right here to the scale tool, and then it's just really fast, kind of cool thing. We've got our base unit, if you would, is a human being, right? And so you can kind of go down and click on each thing that's smaller, 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 or you can use this and slide up. But it kind of jumps in and out by meters, by tens. And so you kind of get an idea of how scale works when you think about how big everything is versus how small everything is. So I'm going to go back to human. And if you want to just kind of take a look at that, you can. There is a question going along with that. And it says, why can't you see individual atoms without special tools? And then go ahead and hand that in. All right, you guys, have a good day, and I'll see you tomorrow.